Welcome members to our channel, YouTube channel, Math in Motion. Shakano is the math tutor. Today, members, I want to take you through about the growth theories. Members, as we know that this time around we shall be going through economics, some mathematics as we go ahead. As you know that this channel is very diverse. Today, members, I want us to talk about growth theories. As we know that economic growth is the quantitative increase in the volume of goods and services produced in an economy. Therefore, in order for a country to grow, it has to go. There are some theories that these economists came up with, and they helped us, and they help the economy to model it and then grow. We have the Harrod-Domar equation, the Harrod-Domar model, the Solos model, and the AK model. We shall be seeing each model at a time. And today, members, I want to take you through how we prove the Harrod-Domar equation. Yes, members, before we begin, let us see how we prove the Harrod-Domar equation. Let me first put off this, and then we shall see how we prove the Harrod-Domar equation. Today, we will talk about the HD model, Harrod-Domar model. Remember, this model was developed by one economist called Harrod in 1939 and Domar in 1946. This model were developed separately, but since they have a lot of things in common, it was brought in together to have a common model. Now, remember, this model, it was developed just as a continuation of the Keynesian theory, the Keynesian economists, as we know of us, that this model just came up to supplement the Keynesian theories that was around by the time. But then this model has assumptions, and then these assumptions are going to help us to derive it. Yes, members, one of its assumptions is it assumes that there is constant coefficient production function. It assumes a constant coefficient production function. What does this mean? This means that under the Harrod-Domar model, it assumes that an economy has a constant coefficient production function. Constant coefficient production function, it means that the production function in this economy is additive isoquant. It first is an additive isoquant. But as we know that the additive isoquant, if we have two factors of production, you have capital and labor this side. Therefore, its isoquant is L-shaped in this format. This is the isoquant, the IC curve. For it being L-shaped, it means that capital and labor are not substitutes, just they are complements. That in order for you to produce any at this level of production, you need a certain amount of labor, which is L star, and then C capital star, in order for you to produce at any level of this isoquant. Like even if you want to produce at this level, you have to use these labor units. If you want to produce at this level, you have to use these capital units. You just increase L. Therefore, labor and capital here are just complements, not substitutes. Yes, by that, another assumption, he assumed that there is no technological progress, no technological progress. He assumed no technological progress. This means that, remember Harrod-Domar, this model is called an endogenous production function, endogenous model, because for it assumes constant, like it is a static growth model. Therefore, we assume that all concepts in the production process are constants. That's why we have no technological progress. And lastly, he assumed that there is constant saving, like there is a constant saving rate. There is a constant saving rate. Yes, members, I think these assumptions will help us dive into how we can prove the Harrod-Domar equation. Members, now let me take you through, without any delay, how we can derive the Harrod-Domar equation. Yes, as we said, the Harrod-Domar equation just came in to just picked from the Keynesian approach of income analysis, where you say that under Keynesian, we say that output, which is economic growth, is a function of consumption plus investment. under a closed economy. Therefore, beginning from here, we say that for a closed economy, this is for a closed economy, total output in an economy equals to consumption plus investment. But also have to remember that investment has to equal to saving for a closed economy. From these are from Keynesian theories, which we know. And but then we say that for the third assumption I had here is that there is constant saving, but this saving rate is the constant of output, like that. Now these questions are going to help us derive our HD model, and then we can see how we can go about it. Now members, after us knowing this, now remember, in order for us to produce goods and services, in order to have Y, we need investment. Then investment, we invest in capital. But if we invest in capital, capital has a depreciation rate. We assume the constant depreciation. We assume capital has a constant depreciation rate. Sigma. Yes. Now, if capital has that depreciation rate, therefore, capital in the future, in the next period, equals to capital in the current period minus the depreciation, because it has to undergo depreciation, then plus the current investment. Then this will give us our capital in the current period. Sorry, in the next period. Therefore, if I bring this k side here, I'll have k plus 1 minus kt. This one is the same as having it minus sigma kt. Now, remember, from here, I just get to know that this is a change in capital stock, which I can denote as the kt plus 1 dt, like this. Or I can name it as, let me call it k star. This is the same as having k star. Change in capital is the same as having the investment, current investment minus current depreciation, something like that. Change in capital stock is the same as having current depreciation, current investment minus the depreciation. Then I have change in capital stock. Therefore, members, from here, I will just need to have my equation like that. But remember, this it is the same as having st and the same as having st minus s minus this. Therefore, my kt, like this, is the same as having, yes, this is the same as having syt minus sigma kt. Kt meaning capital, then yt meaning output. But members, before we go any further, under the Harrod model, these two gentlemen assumed that for an economy, it will always follow a production function. That remember these inputs we have, they are limited and they are complements. Therefore, we have to use certain amount of capital and labor. Therefore, this is going to be a function like output f, so the output yt is always is going to be a function of yes, capital and labor. But remember, output, these capital and labor are always limited. Therefore, they have to put them into, they have to maximize them by putting them into, in order for us to maximize output yt, shall need to minimize, yes, we shall need to minimize, in order for us to maximize, shall need to output y, shall need to minimize these factor inputs because they are scarce, k, and then L, but we shall do out of theta, out of alpha, where theta is the same as having K over L, so K over Y, and theta alpha is the same as having L over Y. By this, I'm just saying that, why are we dividing this one here and then this one here? That if I put back the theta here, I'll have K over Y. If I put K over Y here, I'll have Y. Also here, I'll have Y. Therefore, I'll have one with YT here. Then this alpha, this theta over R is called, as you see, this is capital output ratio. This is capital output ratio. And then the alpha is, I think it is labor output ratio. Just this was a reminder I'd forgotten to tell you about. Then let us come back to our change in capital stock. This I'm calling this one is change in capital. Now, if change in capital is this one, now what do we have to do here? Now, members, from here we have to do, I think, simple things. From here, I'm seeing that we have change in capital as this one. Yes. Now let us go ahead and see how we can now get things done here. Now from here, members, if I divide everywhere by k, yes, I'm saying I'm dividing everywhere by k. If I divide k, I'm saying the next step here is to divide by kt everywhere. What will I have? I will have something like, from here I'll have k star, which is change in capital stock, divided by kt, is the same as having s then yt over what is here, kt minus now sigma kt out of kt. But now sigma kt out of kt, this kt will die. Then I'll just remain with sigma and something like this. But remember, members, I have said that theta is the same as having k over y. Therefore, if I have y over t, y over k, then it's going to be 1 out of theta. Therefore, the whole of this is going to fall to 1 over theta. Here I'll remain with s, then I have the sigma. Sigma, remember, we call it as a depreciation rate. And then now, remember, look here. If I have change in capital stock divide by the capital stock, this is called the growth rate of capital. This is called the growth rate of capital. Why is it called the growth rate of capital? This means that, remember now, like a simple example, if I have, let me give you an example here. If we have, values of GDP, this is this is here. I have here, I have GDP. Then I have 2026, 2025. Then I have some value here like 7, and then here you have like 4. And then you find a change in GDP. Or what do? What percentage change in GDP? Change in GDP. We just get the new minus old divided by old. Yes, I remember this thing. Here I'm getting the change in GDP. Therefore, also here, the change in capital stock. Remember, we said this is KT star means the change in capital stock, which is the same as having the future minus the current. I have this is divided by the current. Are you seeing the meaning? Therefore, this is the growth rate of capital. Therefore, I'm going to call this one growth rate of capital to be. This is going to be. I'm going to note it as GK, and then I have here, I have 1 over 3, then sigma. Therefore, from this question here, I can conclude and say that I can go ahead and say, from here, I go ahead and say that GK, which is the growth rate of capital, equals to S over, then this is, remember, say that theta is K over Y, but then here I have Y over K, which is the same as having over theta minus depreciation. Meaning that in order for me to have the growth rate in capital, I have to deal with savings, I have to deal with capital output ratio, and then depreciation. But remember, we're talking about now growth rate. Growth rate, we said it is output, not capital. Therefore, I have to relate this growth rate in output with capital. Then, members, let us conclude by just saying that can you just put off this, and then we have what to get right. Now, but in order for us to maximize capital, for full employment of capital, we say, for full employment of capital, remember we say that theta is the same as having K over Y. Now from here, let us introduce the the natural logarithm both sides. I have ln theta. Then here I have ln k. But remember this is a fraction. Then it's going to be minus ln y. But remember theta is a constant. Then if I differentiate, now here I differentiate this function to get this next equation here. If I differentiate a constant, I'll have a 0. Then we go to equal to. But now remember, if I differentiating natural logarithms, what we do that we differentiate. We first differentiate this term inside here, then divide it by the actual term which is there. Therefore, if I differentiate this one, I'll have I'll have dk t dt like this, then divide by k. But remember, we said that dk dt is the same as having k star. Therefore, remember, allow me to write a k star here, not this one. Then I'll have a k star like this. Then minus. Then here I have dy dt out of y. But remember also dy dt, I can also write it as y star. Yes, y star. Now from here, as we saw that kt over t is the growth rate of capital. Also, k star over k has to be the growth rate of capital, as we know here. And then lastly, y star over y is also going to be the growth rate of output, gy, from this assessment we made here. And then from there, we shall be able to go and have proven our Harrod equation. I'm saying from this statement here, we just get to know that our 0 equals to, instead of having this one, I have gy, meaning growth rate of capital, and then minus, gk, growth rate of capital, minus then gy, growth rate of output from there. Therefore, from here, I have that my gy equals to gk, but remember gk equals to s minus s out of theta minus sigma. And therefore, I conclude that, therefore, my gy, growth rate of output equals to s over theta minus sigma. And then I have shown that I have proved my Harrod equation. Members, from here, I'm seeing that the growth rate of output, which is our economic growth we're talking about, is a function of saving rate, a function of capital output ratio, and a function of depreciation. That is how Domar came up with this thing, and I think this equation is very important to our lives, and for us economists, we need to know this equation in order to plan and accordingly for the economy. Now, from here, I can also take you through the implications of this model. From this model, we are seeing that in order for us to increase output, growth rate of output, we have to either increase saving or efficiently use our capital or reduce depreciation. But as policymakers, as you said, in an economy, it's always hard to reduce depreciation because depreciation has to occur. If you have a machine, it has to tear and wear. Then also capital output ratio is somehow difficult to control because you have to in order for you to produce output, you have to invest into machinery, and then you have to introduce that. But then here, the saving rate, for the saving rate, you can work with it because if you increase the saving rate, therefore output will also increase. Therefore, members, I think I've tried to explain everything here. For any questions that you don't understand, feel free to reach out to Math in Motion. Just comment any question I'll be able to answer as we go through this course, and we shall be happy, I know, with time. Members, thank you for watching. Second one is your math tutor. Members, endeavor to like, share, and comment for this video because we need to be there. I want to congratulate to everyone who watches this video and subscribe that we reached 1,000 subscribers, but we still now need the watch hours. Members, try to watch this video until the end. I think you shall be enjoying. Thank you, members, for watching. Second one, your math tutor. I'll always be serving you. Therefore, our next video is going to be talking about the Solos model. For Solos model, is going to also be quite interesting. Members, endeavor to watch the next video so as to enjoy. Thank you.